Hi everyone. Today's lecture is going to be a practice for the examination. So it is a repetition of the first 7 weeks. And I'm intended to teach 8 weeks, 8 courses for for the biostatistic course. And I already taught you 7 of them, and this one is the last one, and it will be a practice for the previous 7 weeks. And the practice will be useful for the examination for Committe 3. And I'm supposed to ask 10 questions for this course for Committe 3 for the biostatistic course. And I brought you the 10 questions from the previous year, and I'm going to prepare similar question for Committe 3, but I don't know, and I'm not sure when the examination will be, or maybe you won't have a special examination for Committe 3. You'll have a single examination in the end of the semester. It depends on the coronavirus attack. Hope you had a good rest during these 2 weeks, and you make the most of those 2 weeks studying at your home on your own. So let's get started for this for the last course. Okay, the first question from the previous year was related to one sample mean test. Given that, let me read you the question. The question is, given that the alpha significance level is 0.025 and the population variance is given to be 225 and the sample size you're picking is 25. For the constructed hypothesis, the null hypothesis mu equals 37 against the alternative mu less 37. If the null hypothesis is rejected, what is the maximum value of the calculated sample mean will be? Okay, clearly that this is a left-sided hypothesis, and since the population variance is given, the sigma square is given, so you will know that the test statistics you're going to use for this exercise will be the standard normal distribution statistics. We call it Z calculated. So this is going to be okay, the Z calculated. So this one, remember from the lecture course, was x bar minus mu null and divided by sigma, that's divided by the sample size. Okay, so you need to calculate this value and you check this value whether this value is less than the critical value. The critical value should be obtained from the standard normal distribution table. Okay, let's get try to get this value. So the mu null is for this exercise, mu null is 37. This is given within the null hypothesis, and sigma is the square root of the population variance, which is the square root of 225. That makes 15, and the sample size is also given to be 25. Okay. All right, let's get this value. The Z calculated statistics is x bar. This is unknown. This is the question. You need to get the maximum value of the sample mean. X bar minus 37. That's divided by the square root 15. And the square root of 25 will be 5. So you're going to divide this by 5. And the result is you will end up with x bar minus 37. That is divided by 3. Okay. Okay, you need to reject the null hypothesis. You should have the critical value on the left. So remember the z calculated statistics. I'm going to draw you roughly a graphical representation. Okay, there you go. So it is left-sided. You have in here the rejection part on the left, and this is the accept region. The accept region is in total 0.975. So the alpha levels 0.025. So let me write it. Okay, this is 0.025. That's the rejection part. Okay, the critical value that can be obtained from the standard normal distribution table. It is, I know it already, this value, which is, I'll show you this value from the standard normal distribution table, which is minus 1.96. So, okay, let's get to the standard normal distribution table. So if you go to 1.96, you'll realize that this is that one. Okay, see, this is 0.975 in total. So it is 1.96, the column 0.06, and you have here 1.9, and you have here 0.06. So if you get the intersection, the value is 0.975. So in the z value, the critical value will be 1.96. So it is left-sided, and you should place the negative sign. So this is why it is going to be minus 1.96. If it is less than minus 1.96, you reject the null hypothesis. So it means at most you get the calculated statistics should be at most minus 1.96 to reject the null hypothesis. So it is in fact x bar, sorry about that, x bar minus 37 divided by 3 equals minus 1.96. If it is less, you reject, but if it is equals, it will be the maximum value of the x bar. Okay, from this, the x bar will be 31 1.120. That's the result of the x bar, the maximum value of the x bar. So it means the answer is, okay, A. Okay, let's get to the next question. It's not that hard. The first question. Okay, the second question is, given that, in fact, it's a very similar question to the previous one. The question is only different. The required question is different for this one. Given that alpha level equals 0.025, the sigma square is 225, the sample size is 25. For the constructed null hypothesis mu equals 37, against the alternative mu less 37 if the null hypothesis is rejected, which of the followings can be considered as the confidence interval for the population mean by 95% reliability? Okay. The confidence interval, if you have no idea about the sample mean and you reject the null hypothesis, you're expecting the population mean should be outside the range of the confidence interval for 95% reliability. Um, but but you know that if it is rejected for alpha level 0.025, it makes similar alpha level, the same alpha level for 95% reliability. You will have one on the left side for the confidence interval, one rejection part on the left side, and one rejection part on the right hand side. So it makes in total 0.05 for the rejection level, 0.025 will be on the left side, and 0.025 will be on the right side. So there are two confidence intervals you may use to reject the null hypothesis from the five given options. Okay, one will be the one we should consider as the confidence interval. So if you're rejecting the null hypothesis and you're supporting the alternative hypothesis, it means 37 will be not within the range. So 37 in this one, question A, 37 is inside the range. And in this one, no, 37 is not. And in this one, 37 is not in this range, and 37 is included within this range, and 37 is also included in this range too. It seems that there are two answers, but one is better answer. So we will understand that if you're rejecting the null hypothesis, you're supporting that the alternative hypothesis, they are saying to you the population mean is less than 37. So in this case, question B, the lower bound even 41. 37 is not within this range, but we know that the population mean is going to be less than 37, and even the lower bound is much greater than 37. So question B is not the right answer. So it can't be this one. And this one is not also an answer. Questions, the option C is fine. That's the answer, because the mu 37 is not within this range, and we know that the population mean is less than 37. Even the upper bound 32 is less than 37, and 16 is less than 37. So the correct answer can be easily picked up from option C. So that's the correct answer for this question. So you don't even bother to perform any calculation. So you can easily select the correct answer for this question. So no need for calculation. So question 2, exercise 2, the correct answer is C. Okay, let's get to the next question. Question 3. Given that for the unknown population variance for alpha level 0.10 and the sample size is 22, and the question is, what is the critical value for the constructed hypothesis HO mu equals 37 against H1 mu is less than 37? Okay, this time is the population variance is not given, and the alpha level is changing. It's not the same as the question 1 or question 2. And this is one sample t-test. Remember, for the one sample t-test, and the degree of freedom. To get the critical value, we need to know the degree of freedom. The degree of freedom for this exercise should be the degree of freedom, remember, equals n minus 1, and which it makes 22 minus 1, it is 21. It is a left-sided hypothesis, so the critical value should be the t critical equals t 21. So it is on the left side, so I'm gonna have it as a negative value minus t 21 0.10. So I need to bring this value from the table, student desired t distribution table, and for 21 degree of freedom for 0.10. So I have the table value in here. So I need to pick up 0.10, which is this column. Okay, that column. So I'm gonna pick up this column, highlighting this one. Okay, and the degree of freedom is 21. So I'm gonna let's highlight this in a green color. Okay, let's have it. So 21 is the degree of freedom, so I need this row. Okay, so see that the intersection is 1.323. That's the answer, the critical value, but I need to get the negative sign too as well. So that's the critical value. Okay, 1.323. So the correct answer will be equals minus 1.323. So in this case, the correct answer is B, option B. Okay. Shouldn't take you time. So question 3 and question 4 on the right side. Okay. Which of the following cannot be considered as the confidence interval with 99% reliability when the null hypothesis is not rejected for the constructed HO mu1 equals mu2 against for the alternative mu1 is not equal to mu2 for alpha equals 0.01, and the sample size the sample size picking from this first sample is 14 and the second sample size is 18. Okay, in this question you're not told about the population variances, whether they are homogeneous or heterogeneous, so you don't need to bother about this. If you are given the confidence interval, all you need to care about is whether the difference between mu1 and mu2 is for the rejection is different from 0. So it means the lower bound and the upper bound either will be negative or positive, both the lower bound or the upper bound. And so it means the confidence interval should not include the 0 value. So in the first one, the 0 value is included. Okay, 0 value is in here. Yes, you have the 0 value. 0 value is included. Again, the next one is the lower bound is negative and the upper bound is also negative, so the zero value is also included in this one. And in the option C, the zero is also included. And look at option D, 0 is not included. The lower bound is negative and the upper bound is also negative, so the zero value 0 is included. You don't need to get any calculation to perform any calculations, so the answer is option D. That's the correct answer. Okay, gonna move to the next one, question 5. Given that the alpha level 0.05 and the first sample size is 14 and the second sample size is 18, under the homogeneity variance assumption, what is the critical value for testing the null hypothesis mu1 equals mu2 against the alternative mu1 is greater than mu2? So it is the right-sided hypothesis, so the critical value will be positive, picking from the standard student desired t distribution table. For the homogeneity cases, remember the degree of freedom. Recall that the degree of freedom, we need that, which is n1 plus n2 minus 2. So it makes 14 plus 18 minus 2 becomes 30. That's the degree of freedom. And the critical value is going to be equals t n1 plus n2 minus 2, comma, and the alpha level. So in our case, this is t 30 and 0.05. All I need to bring this value from the t distribution table. I have the t distribution table in here. So I'm gonna pick up 0.05. Okay, I'm gonna have this one. So okay, I'm dealing with this column. Okay, and the degree of freedom, since it is 30, so I'm gonna highlight this with different color. Let's get it pink this time, and smaller one, yes, find this one. So I'm gonna pick up this one. Okay, the intersection is, see that's the critical value. Okay, 1.697, the correct answer. So I don't even to get any calculation. So the correct answer will be 1.697. Okay, that's the correct answer. Okay, question 6. If the null hypothesis is rejected in pair sample t-test for reconstructed HO mu d equals 0 against mu d is not equal to 0, given that 24 paired observations are randomly selected with alpha 0.01, which one of the following is not likely to be the calculated statistics? Okay, if the null hypothesis is rejected for the dependent sample t-test or paired sample t-test, you should either get the value, the calculated t-statistic, either the value is falling on the left-hand side of the rejection path or on the right side rejection path. So you need to get it either on the left rejection or on the right rejection. Let's get the critical value first. So for the paired sample t-test, remember the critical value, I'm gonna use different color. Okay, this one, T critical equals Tn minus 1, and the alpha level, since it is double-sided, this is alpha divided by 2, and I know that this is going to be T23 0.025. Let's get this value from the table. Okay, T distribution table, and 23, I'm dealing with 23. Okay, 23 here, right here. Let's get this different one, pick up blue. Okay, I'm dealing with this row. Okay, and the column is going to be 0.025. So let me pick another color. I'm gonna pick another pink as well. Okay, this is the column I'm interested. Okay, so that's the value I'm interested in. Okay, 2.069. So the answer will be, let's get this value, 2.069. So the answer for rejection, this hypothesis, the T calculated statistics should be statistics is either less than minus 2.069 or greater than 2.069 to reject the null hypothesis. Okay, in this case, which one of the following is not likely? Okay, minus 3.99 is likely to reject the null hypothesis. Yes. For this calculation, minus 3.99 will assure you that you will reject the null hypothesis. It is less than minus 2.069. And this one, option B, is also less than minus 2.069. And 2.2055 is not greater than 2.069, and 299 is greater than 2.069, and 3.99 is also greater than 2.069. So the correct answer is option C. Okay, that's the correct answer. Okay, let's move on to the next exercise 7. In paired or dependent sample t-test, 24 observations are randomly selected for alpha 0.01 level of significance for the constructed null hypothesis mu t equals null against mu h1 mu d is not equal to 0. If the null hypothesis is not rejected, which one of the following can be considered as the confidence interval with 99% of reliability? Okay, in this case, you don't even bother to perform any calculation. You can easily pick up the confidence interval that is supporting your question in here. Okay, you want the null hypothesis not to be rejected. So it means if you're not rejecting the null hypothesis, you need to look for confidence interval that is including the zero value. In our case, this question, the option A is not including the zero value. Okay, can be true. And let's see this one. The zero value is not included in here. The zero value is not included in option C. The zero value is not included in option D. And the zero value is also included. Made a mistake here. Sorry about that. The zero value is also not included in here because the lower bound is negative and the upper bound is negative. The zero value is only included in this option E, and that's the correct answer. So it's pretty straightforward to pick up the right answer. Okay, question 7 is done. We have only 3 questions. We are left on 3 questions. Question 8 is interesting, probably. It is actually not scary. It's should be straightforward exercise. For the following bivariate data set, which one of the followings can be the result of Pearson correlation? Or the question could be for the Spearman correlation as well. No difference. It won't make any difference. Okay, notice that X is always increasing. 2, 4, 6, 8, 10, 12, 14. Each step, the observation value for X is increasing by 2. The increment is 2. And notice that Y is not changing at all. So an increment in one variable, if an increment in one variable does not affect to an increment or to a decrement on the next variable, then there is no correlation. So if there is no correlation, we will think that the correlation coefficient will be definitely 0. So the correct answer is 0. No calculation. No need any calculation. So you can easily pick up the right answer by looking at the data set. Okay. Question 9. We have only 2 left exercises. In a bivariate data set, 38 observations are randomly selected to reject the null hypothesis with alpha equals 0.05 for the constructed HO rho equals 0.5972 against the alternative rho is greater 0.5972, and the question is, what is the minimum correlation of the sample? Okay, if you want to reject the null hypothesis, you need to have at least the calculation statistic should be at least equals to the critical value. For the correlation test, the critical value, remember from the previous 2 lectures, the critical value is Tn minus 2. The degree of freedom is n minus 2, and the alpha level is 0.05 for this exercise. So this is the degree of freedom. So we have 38 observations. 38 minus 2 becomes 36. So you need to go to 36, the row 36, and 0.05. That's the critical value. Okay, let's get this value from the t distribution table. I have it right here. Okay, so I need to go to 36, row 36 is okay. 36, that's the row you should be interested. Okay, that's fine here. Okay, all right. Okay, and the alpha level is, let's get back to the question. I've forgotten, the alpha level is 0.05. That's the alpha level on the grid side, so the critical value will be, so this, I'm gonna hide. So that's the critical value. So I'm expecting to be, the calculated statistics is at least 1.688 to reject the null hypothesis. So I will understand that. So this is the critical value. I will know that the t calculated statistics is, for rejecting the null hypothesis, it should be at least 1.688 to get the minimum correlation. So the minimum correlation, the sample correlation, R, X, and Y for the Pearson. Remember, this is, we show it in this way. This is minus 0.5972. That's the calculated statistics, and that's divided by the standard error of the correlation, which is within the square root. I have 1 minus r xy square, that's divided by 38 minus 2. Okay, and this should be at least 1.688, and the correlation coefficient for this, if you perform your calculation for this one, it's not easy, probably the calculation, maybe it takes time, more than a minute, but you can easily use each option and place each, substitute each answer within the calculated statistics, and whether it satisfies 1.688. You can maybe, if you use this way, you may get the answer in a shorter time. So I'm not gonna perform this calculation for you, but if you try to do it yourself, and you'll see that the answer is 0.80. The answer, I know this answer from the key answers, 0.80. So the correct answer is 0.80. Okay, fine. All right, and the last question, finally. Given that n equals 38 and the alpha level of significance is 0.05 for the constructed null hypothesis, rho equals minus 0.75 against the alternative, rho is not equal to minus 0.75, and so the question is, which one of the following can be considered as the confidence interval for the population correlation with 95% reliability when the null hypothesis is rejected? Okay, if you're rejecting the null hypothesis, your confidence interval should not include minus 0.75. So there is no need for a calculation. All you need to look for the correlation coefficient minus 0.75 is outside the range of the confidence interval. In the first option A, look at option A, minus 0.90 is less. So the minus 0.75 is not included. Okay, if we are rejecting the null hypothesis, that is correct. This confidence interval is correct. And the next one is not also including the minus 0.75 is not including, fine. And this one is not including minus 0.75, and the next one is including, this is including minus 0.75, and this one is also including minus 0.75. So question D and E is eliminated directly because the correlation coefficient minus 0.75 are included, is included in both options. Okay, let's see. We need to eliminate two of them, A, B, C. From A, B, and C, one is correct. Remember that the Pearson correlation or the Spearman correlation doesn't make any difference. It's always between minus 1 and 1. So in this case, option A seems to be okay. No problem for question option A. And option B, look at that, you have minus 1.8555 is outside the range of the correlation coefficient, which is impossible. We don't observe the Pearson correlation to be less than minus 1. And we also, in option C, okay, seems that, okay, 1.1 is also greater than 1. So it means question B, option B and option C cannot be considered as the confidence interval. So the right answer is A. Okay, this is the end of my last lecture for Committe 3, and I really enjoyed teaching you this course from Committe 1, Committe 2, and Committe 3, and we had 2 lectures online due to the coronavirus attack, and I hope you will enjoy your resting at home. And somehow, if you need me to ask, if you want to ask something, you can get me easily by email, writing an email to me at any time you like at gatila@mu.edu.tr. That's my email address, and you can't see me at all anymore because you're not allowed to get to the campus of the university until at least to the end of April, as far as I know. But you can easily get to me by writing to me. But if somehow you need to get me by phone, just write me an email and leave your number. I will call you to answer any of your question. Thank you for listening this course, and I wish you a very good luck in the examination. I wish you a very good luck in your life. Take care of yourself and each other. Bye for now.